Today I will present Norman Digital Sample Freezing Platform, which is a European virtual platform to exchange and screen high-resolution mass spectrometry data. I will briefly introduce you to the Norman Association and the Norman database system, and more specifically I will talk about the suspect list exchange, the substance database, and the ecotoxicology database. I will provide, however, more details on Monday 23rd at 14:35. Afterwards, I will talk about DSFP, the current status, and upcoming integrations. Norman Association is a network of reference laboratories, research centers, and related organizations focusing on contaminants of emerging concern. It consists of 10 working groups, and obviously the most interesting group for this specific event is the non-target screening cross-working group. Moreover, Norman has established its own databases and what we call the Norman database system. It consists of several interconnected databases. One of the most important is the suspect list exchange. Suspect list exchange is the place where we store lists of environmentally relevant substances. And up to date, we have more than 95 such lists of compounds. These lists are merged together to form what we call the substance database. Therefore, substance database has up to date more than 109,000 substances. And of course, within Norman, we gather a lot of information about these substances. DSFP uses the substance database for performing retrospective suspect screening. Initially, in 2019, when we published this article, the aim of DSFP was to collect data from various laboratories, which are obviously equipped with different instruments. If we manage to bring this data to a common repository, then we can create a graphical user interface with which the data and the people, the researchers, can interact. More specifically, what we did was to create a non-target screening workflow in which the MZML files will be processed with a peak picking algorithm. Afterwards, they will be grouped to form the components. Then the experimental retention time index will be calculated, and this is because we need to normalize the retention time dimension of the chromatograms, and finally add MSMS spectra to form the final data collection template. The data collection template, which contains the component lists and MZML files, end up in a central place, the server, which is interfaced by DSFP, which is the user interface. The advantage is that the users can search for known substances already in the Norman substance database or new substances and perform their retrospective investigations. DSFP, the prototype of DSFP, has been successfully developed, and we received a significant contribution from the Norman Association to upscale DSFP. Therefore, here you see this upscaled website. It consists of a bar, a search bar, where you can search the contributions, the collections, and the data using keywords, exactly the same you do with Google or Microsoft Bing or any other search engine. Of course, there is a contributors area, a data area, an about area, and of course the top bar will be improved and more elements will be added in the near future. Finally, there is a user area where the contributors can upload their chromatographs and their data. Of course, someone to become a contributor has to either have an account and log in or sign up and create an account. The procedure is very simple and straightforward and is the one that you follow in every website. Once logged in, you will be redirected to the contributions, and a completely new laboratory, a new contributor will have, of course, zero metrics in labs, in instruments, in collections, and in files. Therefore, the first thing to do is to add the laboratory for your organization by pressing the Add a Lab button and then specifying the lab name, providing a short description, address, logo, basic information. Each laboratory has one or more instruments, so let's go and add them as well. So when pressing the Add an Instrument, someone has to specify an instrument alias, a short description, the manufacturer, the model, where it belongs, in which laboratory this instrument belongs, and the instrument type. And very basic information. Once an instrument is created, then one instrument can have one or more different instrumental setups. This is very straightforward. By clicking here, someone can add a setup, and in this setup, a setup alliance again has to be filled in, the ionization, the instrument for which we contribute the specific setup. Then we have the separation settings, which means the different settings for the liquid chromatography or the gas chromatography. The detection settings, where we have the detection settings, the HRMS part, and also the algorithmic parts, which means the peak picking parameters and the componentization parameters. Finally, someone has to provide also the retention time of the RTI calibrants, which helps to normalize the retention time dimension of the LC HRMS or GC HRMS data. Of course, for GC HRMS data, we use the N-alkanes and not these calibrants. And finally, optionally, someone can provide the spiked compounds. This is incredibly useful when we perform semi-quantification of the results. And of course, it's absolutely needed when these data are used for example, performing prioritization exercises. Once the laboratory is there, the instrument is there, and at least one setup for this instrument is in place, then we have the collections. Collections is a group of samples gathered, for example, during a sampling campaign. There is, again, a button, as in previous cases, at the collection, where the user specifies various information, like the title, the subscription, the public access level. This is quite important because maybe you decide to restrict the access, or maybe not. And there are other important information someone has to fill in. For me, the most important is the keywords, the tags, because the search in the front end of DSFP is a search for the keywords. The more keywords someone uses here, the better. Okay, we added a collection. Now let's go and add samples. We have to click on these 20 samples. Now it says it could be 0 samples, and afterwards add a sample. And then we have to select the sample type. Is it a blank? Is it a QC? Is it a sample? Provide the short name, sampling date, analysis date, which instrumental setup we used to acquire this information, the geographical data, and then the matrix type. And we collect different metadata for each matrix. In this case, you see environmental monitoring and groundwater. But as you can see, we try to expand our investigation also to human biomonitoring and foodomics. Therefore, there is the possibility to upload this type of data as well. At the last stage, we contribute the MZML data, and here there are many options because we have a wide variety of instruments and instrumental acquisition types. Therefore, someone may provide the full scan, the data-dependent acquisition, and the data-independent acquisition. Of course, there is a possibility that someone does both data-dependent and data-independent acquisition. If this is the case, then we can upload more than one file. And finally, press submit. Once the collection is complete, it will appear in the contributions. It will be searchable from the front end, and it will be indexed by search engines like Google or Bing or any other search engine. Now, let's move to the future plans. One future plan is to import the existing samples. We are halfway there. As you can see from the map, we have various samples from various matrices, from many projects, and here you see the spatial distribution. Of course, we lack samples from America, from the States and America, but we have a few of them from the Latin America and from Antarctica. However, there is huge space of improvement here. Second thing we want to transfer to the new system from the prototype is the batch searching of hundreds or thousands of samples in the digitally archived samples. which I think will be quite straightforward and quick to be done, and also integrate the suspect screening with prioritization exercises. Unfortunately, I cannot enter in details here, but there is a whole working group focusing on the prioritization of contaminants. And here, I don't mean non-target screening prioritization, but prioritization of substances for chemicals management. Moreover, there are many visualization tools that have been created from other projects. These visualization tools, for example, there are tools for viewing the spatial distribution, for performing network analysis, addressing the co-occurrence of substances, or time trend analysis. All these tools we will transfer to the new upscaled website. Take-home messages. DSFP will help you to keep your high-resolution MS data well organized. It will help you to comply with the FAIR rules, which is absolutely important and mandatory, at least for European projects. It will help you gain insights because of the visualization and the statistical tools that are integrated and will be integrated in the future. It will make your data available to the scientific community, and DSFP stimulates cooperation among researchers. It enables wide-scope retrospective suspect screening, and it will help you gain visibility, not only in DSFP, where there is a contributors area, but also in search engines like Google, because the results and the contributions are indexed, and also in academia, because we plan to have a DOI for each collection. Finally, it will help us a lot to have a critical amount of data, which is absolutely needed when we deal with regulatory frameworks. And the aim and the goal, the future long-term goal, is that the DSFP can act as a safety net and as an early warning system for chemicals in Europe and beyond. And here there is strong connection with PARC, which is a pan-European big project. Therefore, my message to you is to create your DSFP account today at norman-data.eu. And I would like with this to thank you very much for your attention.